let's do one and see what happens here. So our second example is going to be, let's mix a solution. Well, let's actually spell out the problem. What happens when a solution of magnesium nitrate, which let me write it over here, don't have enough room, solution of magnesium nitrate, which is MgNO3 and potassium iodide are mixed. Okay, well, let's write out the molecular formula, see what we get. That's MgNO3 plus Ki. We want to write the molecular formula, so all we do is switch partners. Magnesium and iodide, they come together. It's going to be Mgi2. And then potassium and nitrate are going to come together. So it's going to be KNO3. Now I want to balance this. That's the first thing I do once I come up with a molecular by switching partners. There's one magnesium. There's 2 nitrates. There's 1 nitrate here, so I put a 2, which gives me 2 potassium. I stick a 2 in front of the K on the left. That gives me 2 potassium. That gives me 2 iodide. There's 2 iodide on the right. I'm fully balanced. All I needed was a 2 here and a 2 there. Oops, some random lines are showing up again, which we do not want. Okay, let me put that Mg there. So now let's check for solubility, because that's what we do next. Well, magnesium nitrate is fully soluble. Therefore, we have Mg2 plus 2 NO3 minus. Okay, potassium iodide, fully soluble. Therefore, we have 2 potassium ions, 2 iodide ions. Well, now let's look over here, magnesium iodide. As it turns out, magnesium iodide is also soluble. Therefore, you have magnesium 2 plus 2 I minus, and potassium nitrate, definitely soluble. So 2K plus 2NO3 minus. So notice in this case, you ended up with, you mixed a solution, 2 solutions where both things are fully soluble. And when you switched partners, you ended up with, well, something where both of the products are actually also soluble. So what's going on here, even though you can write a molecular formula, switch partners, there's no chemistry going on here. All that's really happening is a bunch of free ions floating around, slamming into each other, then coming apart again, because everything is soluble. Every combination is soluble. So really, there's no reaction here, even though we can write a molecular formula. So that's what's really important to remember. Just because you can write a chemical equation doesn't mean there's any chemistry going on here. Chemistry means something changes. Magnesium, nitrate, potassium, iodide on the left floating around free in solution. Magnesium, iodide, potassium, and nitrate floating around in solution on the right. There's no difference. Everything cancels. Nothing happens here. There is no net ionic because nothing actually happens. So that's the important lesson. So take a look at your 2 ionic compounds, write a molecular formula on the left, switch partners, and write the appropriate chemical formula on the right, and then go back to the reactants and do the total ionic. See which one of those 4 compounds that you have is soluble and which is not. That'll be your total ionic equation. And then you cancel similar species in the total ionic that's on the left and on the right, like we did for, well, both of these examples. And what you're left with is your net ionic equation. Your net ionic equation is the chemistry. Here, the last example, there is no net ionic, there is no chemistry. So just because we can write it doesn't mean that something is actually happening. These things don't really exist as compounds. They're soluble. They're just floating around free in solution. This, the total ionic, is what's telling you everything that's going on. Nothing is hidden. This tells you that nothing is going on. And again, your intuition should be just as good. You know that free ions floating around, they slam into each other. There's nothing here that's mysterious. Just have to follow the logic. Okay, So thank you for joining us here at Educator.com for the discussion of precipitation reactions. We'll see you next time. Take care.